All right, so today we're going to talk about functions and function notation. So you may have heard of a function before. In order for a graph to be a function, okay, all that means is for every single x, there's exactly one y that goes along with it, right? So below I have a series of ordered pairs of points, right? And any series of points like this is something we're going to call a relation, because they're just a bunch of points, right? And so this relation, what I want to look for is I want to see if for every x there is only one y. So we don't want repeating y's. Okay. So if I look at these, all of my x's are different, and indeed, all of my y's are different. I have a 1, a 0, a -1, and a -6. Okay? So this relation happens to also be a function. Okay? Because for functions, there should only be one y for every x. So this relation also happens to be a function, and that is not always true with relations. Okay? So all functions have to be relations, but not all relations are functions. Okay? So a relation is just a group of things together. Okay, so let's look at this relation here below. So this is a relation. And what I want to look for is to see if this relation also happens to be a function. All right? So I have 0 and 3, 5 and 2, but then I have 4 and 3. Is that allowed? Okay, I have repeating y values. Let's look at what this looks like really quick on a graph, because a lot of us like to picture things. So I'm going to make a quick graph. I have 0, 3. I have 5, 2. I have 4, 3. And I have 2, 4. Okay, so is this relation a function? Yes, it is. What we are looking for when it is not a function is, let's say, something like something that looks like this. So let's say I have these 2 points, 2, 3, and 2, 4. And I'm going to reuse my graph. If I have 2, 3, and 2, 4, look what happens to those 2 points. They're right above each other. Okay, so as this relation is a function, this one has x values with 2 different y values. Okay, this is not a function. Okay, so sometimes it's really helpful to go ahead and have these visually in front of you. So let's go ahead and look at something here. First of all, are all of our lines going to be functions? And the truth is, for lines, they almost all are. Okay? So we can test visually by using something we call the vertical line test. And the vertical line test says if I go ahead and draw a vertical line, that's an up and down line, I should only touch the graph at one point. Okay? So if I take graph 1 here, and I go ahead and draw vertical lines, Each of these vertical lines I'm drawing only intersects my graph at one point. So a line with a positive slope is a function. Okay, what about a line with a negative slope? Okay, again, I'm going to draw my vertical lines. And again, they only intersect this line at exactly one point. This is also a function. Let's look at my line. This is my y equals line. Okay, so this has a slope of 0. And again, if I go ahead and employ my vertical line test, it still is only hitting that line at exactly one point. This is also a function. But when I go ahead for the last graph, I'm going to call graph 4, this is my x equals line. And if I go ahead and draw vertical lines, when I get to that vertical line, I hit every bit of that line. I'm hitting that line as many things as I can have points for. Okay, so this is not a function. So going back to my example here, these 2 points create a line that goes like this. This one visually would be not a function. All right. Let's go ahead and look at what we call function notation. Now, you can only use function notation when it's a function. Okay? So remember back in the day when we would have an equation, we'll say y equals x minus 3. And we wanted to know the value of y when x was equal to 7. So what we would do is we would rewrite our equation. Wherever x was, we would go ahead and put a set of parentheses. Oops, shouldn't be 7. Okay. And wherever there was x, I would go ahead, put the value I was given, and just do the math and see what y equals. So in this case, y is equal to 7 minus 3, so y would be equal to 4. Okay. Rather than write all this stuff here, I want to go ahead and make it more compact. Okay. So instead of that, I would say, okay, I have an equation, y is equal to x minus 3. But instead of all the stuff I circled in blue, I would just write my notation f of 7. So what does this mean? Okay, so another way to write the equation that I have, the y equals x minus 3, another way to write that is f of x is equal to x minus 3. And all f of x means, that means it's y. Okay. The value inside the parentheses is an x value. So in this case, inside the parentheses, I have a 7, which would mean that wherever there is an x, I'm going to replace it with 7. It means the same thing as all these words right up here. Okay? So if I have f of 7, and I have this equation, now I would be given this equation, and I would be given find f of 7. That means exactly the same thing. So I would go ahead and I would say, okay, well, f of x, or f of 7, pardon me, is equal to 7 minus 3, which, so f of 7 for this equation is equal to 4. All right, let's go ahead and look at a few more examples. So here I have an equation, and I wrote it originally in y is equal, but remember we want to use function notation. So I'm going to take that y out and replace it with f of x. Okay, that's all y means. Okay, so remember y is equal to this f of x thing. Okay, and I want to find f of 2, which means I need to go ahead and plug in 2 into this equation. So I have negative 4, and there's my x, minus 2, and I'm going to replace my x with 2. So therefore I have negative 8 minus 2. So f of 2 for this equation is equal to negative 10. Okay, let's try f of 0. So doing the same thing, I have negative 4 times 0 minus 2. This is going to become 0, so f of 0 in this case is negative 2. Last one, I'm going to find f of 1. So I have negative 4 times 1 minus 2. So I have negative 4 minus 2. So f of 1 in this case is going to be negative 6. Okay, and we're getting close to Thanksgiving break, so we're kind of introducing a few things. We are going to be talking a lot more about this, not necessarily in our lines section that we are doing here, but we're going to see it again very soon when we're talking about an idea of quadratics. But it's nice to go ahead and see the notation now so that when we redo it again, you've seen it before. So go ahead, make sure you work on the practice problems, and I will see you in the next video.